Hi class, today we are going to do Unit 1, Lesson 4, Right Triangle Trigonometry, and we're hoping by the end of this lesson that you can remember how to find missing sides and missing angles in right triangles. Trigonometry is used in many areas such as navigation, surveying, astronomy, measuring distances, etc. Let's start by thinking back to our two special right triangles, the 45-45-90 and the 30-60-90. Beginning with the 45-45-90, remember there's two 45-degree angles and a 90-degree angle. Can you remember the ratio of the sides? So remember the legs have the same length, so they have a ratio of 1:1, and the hypotenuse is √2. So however long the leg is, you multiply by √2 to get the hypotenuse. In a 30-60-90 triangle, so remember each angle is 30, 60, and 90. The shortest leg is across from the 30, so we'll put a 1 on the shortest leg. The hypotenuse should be twice as long, and the longer leg should be times √3. So the ratio of the sides is 1:2 to √3. Now this is true in all 45-45-90 triangles and all 30-60-90 triangles because they are similar to each other. They are proportional to each other, and they always have these ratios. So let's carry that forward. Think back to your days in geometry. If you were given two triangles and you were trying to figure out, are they similar to each other? In other words, are they the same shape, just different sizes? One of the things you could check for is the angles. And if they had 2 or 3 angles that were congruent, that was enough information to know, hey, they are similar, they're the same shape. So their sides, their corresponding sides, would have been proportional. Imagine if we needed to memorize all of the right triangle proportions. Like we memorized the 45-45-90 and the 30-60-90. What if we had to memorize the 20-70-90 and the 21-69-90 and the 22-68-90, etc.? You get where I'm going with this. It would be too much, right? It would be too much to memorize and not very fun. Well, there was a guy who back in around 140 BC figured all this stuff out. He figured out that right triangles, if they were similar, they always had proportional sides. And so you could use one triangle to try to find missing measures in another triangle. And just like we memorized the 45-45-90, this guy started writing down all these different measurements and proportions. So I'm not exactly sure how to pronounce this, but we'll say Hipparchus is considered the founder of trigonometry. He constructed tables for a function closely related to the modern sine function and evaluated angles at half-degree intervals. These were considered the first trigonometric tables, and he used these tables mainly to calculate paths of planets. Now, that original chart eventually evolved into something like this. And you can see, like, let's go down here. Look at where it says 45. These are the ratios between the sides of the 45-45-90 triangle. Like right here, the ratio between the legs is 1:1. Here, the ratio between one leg and the hypotenuse is 0.707 to 1. And same thing with the other leg because those two legs are the same size. For many years before calculators were really popular, and this is probably even in the era of your grandparents, they used this chart to do trigonometry. And so they would look up the ratio between sides, and the different ratios had names. You might recognize some of these things up here at the top, sine, cosine, and tangent. And they would use this chart to calculate various side lengths in triangles and angle measures. Nowadays, all of these ratios are programmed into our calculators, and so we really no longer have to refer back to this chart. We just use our calculator, which is programmed with these numbers, and it is able to do the ratios for us. But because of that evolvement with trigonometry, many people were able to take it further and study things that had never been studied before. Again, excuse my pronunciation here, but Aristarchus of Samos, he was a famous Greek scientist, musician, astronomer, and geometer, and in his book on the sizes and distances of the sun and the moon, he estimated the distance to the sun by observing that when the moon is exactly half full, the triangle formed by the sun, the moon, and the earth was a right triangle at the moon. And so he used trigonometry to start calculating those crazy distances way back in around 310 BC. 18 years later, people were still trying to figure out some of his ideas and accepting them. So science was really evolving during the same time as trigonometry. Let's review the three basic trigonometric functions. They are called sine, cosine, and tangent. And I know you've learned these in geometry, and then you learned them again in Algebra 2, and now we're going to review them again. And this will really be the basis for the rest of this trimester. So one thing that you may not have seen before, may or may not have, is this right here, this symbol in this angle. This is pronounced theta, 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 and it is a Greek letter. It's a part of the Greek alphabet, and it's often used for angles in trigonometry. So remember, based on this angle, we have sides that are called opposite, adjacent, and hypotenuse. So the A is across from theta. That would be considered opposite of theta. The B is right next to theta. It comes in here and touches the angle. Now, so does C. However, C is already the hypotenuse, because remember, hypotenuse is always across from the 90, and it's the longest side in the triangle. So C is our hypotenuse. So that leaves B for the adjacent side. Next, please direct your attention up here to this little saying that I'm outlining, SOH CAH TOA. Now remember, this is the shortcut for remembering the trigonometric ratios, the basic functions. So sine is opposite over hypotenuse. Let's jot that down. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So if we look over at our picture and we wanted to find the sine of theta, I go to the side that's opposite of theta, which is A, and the hypotenuse, which is C. If I want to find the cosine of theta, I have to do the adjacent side over the hypotenuse, which adjacent is B, hypotenuse is C. If I want to find the tangent of theta, I do opposite over adjacent, which in this case would be A over B. Some other ratios that might or might not look familiar include cosecant, secant, and cotangent. Now these are the inverses of sine, cosine, and tangent. So all you have to do is take the reciprocal of what we had. So cosecant is actually going to be the reciprocal or the inverse of sine theta. So it's going to be hypotenuse over opposite. And secant is the inverse of cosine, and so that's going to be hypotenuse over adjacent. And tangent and cotangent are inverses, so you flip that over and you have adjacent over opposite. So again, if we find our ratio, the cosecant of theta would be hypotenuse over opposite, which would be C over A. Secant would be hypotenuse over adjacent, which is C over B. And then cotangent would be adjacent over opposite, which is B over A. Please recall that when it says solve a right triangle, you're finding all the parts of the triangle, which is going to include 3 angles and 3 sides. Example 1, solve the right triangle. This means we have to find all the missing angles, all the missing sides. Now recall that the 3 angles in a triangle always add up to 180, and we're given 2 of the angles. So to find angle Y, we can pretty quickly do that if we just do 180 minus 90 and minus 35. And we wind up with 55 degrees, which is going to be the measure of angle Y. To find x and y, we're going to need to use trigonometry. So one way to do this is to remember SOH CAH TOA, SOH CAH TOA. Mr. Winters once taught me to write it like this, then you remember what's on the top of the fraction. So I thought that's kind of cool. All right, so let's try to find x. Now, I like to use the angle that they give us. So in this case, they gave us the 35. X is opposite of that angle. The other side that we know is the 10, and 10 is adjacent to the 35. So we're working with opposite and adjacent, which is part of TOA. You can see the O and the A there. So we're going to choose tangent, and we're going to go tangent of 35. Remember, it's always the angle that goes in there, equals, and now order matters, opposite over adjacent, so x over 10. This one's pretty nice for solving. We can just multiply both sides by 10. These 10s will cancel, and then you're going to have to grab your calculator, and you're going to type in 10 tangent 35 equals, and you should get 7.002. In trigonometry, we will always have you go to the thousandth, which is 3 decimal points. So we need to be a little more precise now than we were in geometry and algebra 2. So again, always go to 3 decimal places. Next, let's try to find z. So if we look at z, according to this angle 35, z is the hypotenuse in the triangle. So I'm going to use the 10, and I want to find the z. So those are going to be the two sides I'm working with, which are adjacent and hypotenuse. If you look at your ratios, adjacent and hypotenuse go with cosine. So we're going to choose cosine, and we're going to say cosine of 35 equals 10 over z. And that is adjacent over hypotenuse. Now to solve for this one, it's a little trickier because z is on the bottom of the fraction, not the 10. So I usually do this. I usually start by multiplying by z, getting that off the bottom of the fraction. And then over here I have z times cosine 35. So next I'm going to have to divide by cosine 35 to get z by itself. Whatever I do on one side of the equation, I'm going to do on the other. These cancel. So I wind up with z equals 10 divided by cosine 35, and that I can type into my calculator. And when I do, I get 12.208. Please take a minute and actually type those in your calculator and make sure you're getting them correct. If you're not, it's probably because your calculator is in the wrong mode. This is really important. The mode in your calculator needs to be in degrees. This is very important, otherwise you will not get the correct answer. So check that out. Go find your mode button. It's probably on the top left somewhere, and see if you're in degrees. If not, it's about the third or fourth thing down. You might have it in radians, so you might have to arrow down and change that from radians to degrees. Then try it again and see if you get these answers. Cool. Please pause the video and try example number 2. Try A, B, and C, and then when you're done, unpause the video and see if you get them correct. Part A, I would multiply by 12. These will cancel out, and then I just type in my calculator 12 times sine 40. And so when I type that in, I should get 7.713. This time, part B, I'm going to have to multiply by x first, and then I'm going to have to divide. So I'm going to have x cosine 18 equals 62. Then I'm going to divide by cosine 18. So x equals 62 divided by cosine 18, which when I type that in, I got 65.191. And last but not least, I would multiply by 110 on both sides. And then I would just type in 110 times tangent 62, or 110 tangent 62, and x should be 206.880. Again, round to the thousandth, 3 decimal places. Moving on, now you can see in example 3, we're going to solve for theta. So we're going to try to find a missing angle instead of a missing side. And so to get theta by itself, I have to get rid of the word sine. And to get rid of the word sine, I do a thing called inverse sine. Now, inverse sine is sine with the little -1 above it. Whatever I do to one side of the equation, I do to the other. And so here on the left, the sine and the inverse sine cancel, and I'll wind up with theta equals the inverse sine of 3 divided by 7. And that I can type into my calculator. So remember, they're above the sine, cosine, and tangent buttons. So you're going to have to hit second and then sine. So again, you're going to hit second, and then you're going to hit sine, and then you're going to go, probably a parenthesis will already show up, and then you're going to do 3 divided by 7. You can close the parenthesis if you want. I don't think it's required on your calculator. And what should happen is you should get theta is 25.377 degrees. Again, round to the thousandth. Let's try part B. So to get theta by itself, we have to get rid of the word cosine. And so to get rid of the word cosine, I'm going to do the inverse cosine. They cancel each other out. So I have theta equals inverse cosine of 5 divided by 8. I type that in my calculator. I go second cos, 5 divided by 8. And this time I get 51.318 degrees. Make sure you label it because it is an angle and the measure is in degrees in this case. Go ahead and try part C. So you should be doing inverse tangent of 11 divided by 4. And when you type that in your calculator, you should get 70.017 degrees. Again, if you're not getting the correct answers, then your calculator might not be in the right mode. So make sure your calculator is in the degree mode. Example 4. So let's try to solve for theta. So I see theta is down here in this corner, and I see two sides have writing on it. One is the 18. Is that opposite, adjacent, or hypotenuse to the theta? It is the adjacent side. It's right next to it. It touches it. How about the 43? 43 is opposite. So now you have to think about SOH CAH TOA. And you have to pick one of these ratios, and you want to pick the one with opposite and adjacent in it. Opposite and adjacent go with TOA. So you should write tangent theta equals opposite over adjacent. And there's your equation, and now you solve the equation. You want to get theta by itself, so you're going to have to get rid of the word tangent. To get rid of the word tangent, you got to take the inverse tangent. Whatever you do to one side, do to both sides. These will cancel out. Theta is going to equal the inverse tangent of 43 divided by 18. And at this point, you grab your calculator and you type that in. 67.286 degrees. Great. Please try the last one on your own. Pause the video for a second and give it a try. Here's your theta. 15 is opposite, 6 is adjacent. Opposite and adjacent go with tangent again. So you're going to do tangent theta equals opposite over adjacent. So 15 over 6. To get theta by itself, you got to get rid of the word tangent. So you'll take the inverse tangent on both sides. And you'll have theta equals the inverse tangent of 15 divided by 6. Type that in your calculator, second tan, 15 divided by 6, and theta should turn out to be 68.199 degrees. Awesome. So hopefully you can say that you can remember how to find missing sides and missing angles in right triangles. Next, will you please try Unit 1, Practice 4? If you need help, just let us know. Have a great day.